Today I want to show you how to run some of my examples, ones that may not be so easy to execute in modern environment like Windows or Linux. As you can see, I have DOSBox ready here. So I'm going to be running something in DOS. And let's start with the latest release of Tetros. So we are going to download it. And copy it into this DOS machine. So now let's go to DOS. Let's do a rescan for DOSBox, and we can see the files here. We can even try to reassemble this. Oh, okay, we need DPMI first. So I'm going to install some DPMI. And in FASMD we can press Ctrl F9 to compile, but Ctrl F9 normally is a shortcut to close DOSBox. So it would you will need to remap the key to get this shortcut working, like for me here. Or we can just use command line FASM. And we have a fresh image file. What is especially nice about DOSBox is that there is a special boot command that you can use. You can use it to boot an image immediately. And we have Tetros working now. This version changes colors every time we restart it. I can even hold down the key to do it very quickly. And you can see that the colors are not completely random. This is just cycling through entire color palette. But it is cycling synchronized with the system clock. So when I just press escape normally to restart, then the choice of color appears to be random, because it depends how much time has passed. Now you can see I have a running DOSBox and a screenshot on the same screen. Now let's try something harder. Let's go to the examples section. This is a section with examples that were written a long time ago. As you can see, this Calvar is one of the first examples published for FASM. And it is very hard to run it on modern systems. And I'm going to show you why. So let's download it. And copy it into DOSBox. And let's see what can we do. Alright, there is this make here. We need to have FASM in the path variable. Wait, I can do it here. Yes, DOS Navigator has this option. Let's try. I'm not sure if this is going to work in DOSBox. Oh, okay, DPMI. I have it here. Great, assembly succeeded. Keep in mind that this is in the emulator, that's why it is slow. So now let's try to run this example. And here is the problem. Even when we have an emulator like DOSBox, we still cannot execute this, because this example uses my 32-bit Unreal mode, which is so rare that most emulators don't even support it. But fortunately, I have checked that Box emulator handles it properly, so we can try to run it there. So now I'm going to mount disk image that I use for the Box emulator, and copy this example there. And let's try it with a better emulator. Okay, it has even detected Sound Blaster, but with wrong settings. I'm going to talk more in a second about it. There was also some timing issue, that fade out should have been faster normally. Let me show you on the full screen, because fragment of the image was cut. Okay, we need to add some mouse support here, but we also can steer with keyboard. Oh, definitely some timing issues are here. It runs way too fast. One thing that I noticed when I was trying this earlier is that the second time I ran it, the DMA is detected properly, because it should be 1, not 0. And I'm not sure why this is happening. Perhaps this is also an issue related to timing, or perhaps a bug in this code. This is something I written while I was teenager still, so there certainly can be some bugs. Okay, you may be hearing a music played by this code. This is an 11 kilohertz 8-bit wave file, so the quality is terrible. And we still have no mouse. Yes, we can still hear the music, so it means that the emulated program was playing it faster than the system is now playing the music, so it is buffered. Okay, here I have some mouse driver. Okay, here is an option to capture the mouse. So we can now try if mouse works here. As you can see, it has detected DMA 0 again. Yes, I think this is the standard package for Windows, this version of Box. And you can see the mouse is working now. This was just a bare engine. Not much has been done here to make some actual game out of it. It was just a proof of concept for various mechanics of the engine itself. And this is quite interesting that it detects DMA correctly every other time. I'm not sure why this is happening. It's somewhere here. IRQ. Oh, okay, it's here. We are first testing for DMA 1 and then for 0. So this means that the first time the program is run, it fails this check. But the second time it does not fail. And the way this check works is that it starts DMA transfer of just a single byte. And looks whether an IRQ happened. So we have an IRQ here. It marks a flag in this variable, and this flag is tested here. So this means that the first time that we try it, the IRQ does not fire for some reason. And perhaps it arrives delayed, but this is not a full explanation, because if it arrives delayed, then it would detect DMA 0 every time, and it does it every other time, so there is something strange happening here. And I'm not sure if I can find out now. But I can at least try different settings for those for bugs to try to make the game run a bit slower, because it runs too fast right now. I can try changing this setting. I had some problems with the lock, but it's okay now. Let's see. Oh, I'm going to install the mouse driver again. Well, it seems slower, although this part should not be this slow. It's very hard to get clock interrupt work nicely in those in-box emulator. Perhaps someone more knowledgeable could give me advice how to use it. Oh, okay, this looks like a correct speed, at least here. Oh, one more important thing here is that I've been tweaking this configuration, and for example, Sound Blaster was not enabled by default. But if you run it in a default configuration with no Sound Blaster, then at least you're not going to have this problem that DMA is not always detected properly. Although the bug is not random, it detects it correctly every other time, so this is quite interesting. Okay, so now it got it correctly. Yes, and remember that the reason that we have to run it in this emulator and we could not in DOSBox is because this is running in real mode, but it is a 32-bit code. This is quite unusual thing to do. A 32-bit code as in not requiring prefixes to use 32-bit registers. And for this reason, on later machines there was no difference, but on 386 machine, this Unreal mode with 32-bit code would have really great performance, because real mode was faster than protected mode back then, and if you could combine this with not requiring prefixes to use 32-bit addresses, and then you really had the best performance possible, I think. I'm probably going to make some cuts here to make a shorter YouTube version of this video. And you may be right, perhaps it could be worth it to put a link somewhere nearer to the actual example. So this is the Unreal server. The same that I also used for Phasmilator. Oh, here you can see the test. We are putting this value into EBX register, and then we try to enter 32-bit real mode. And this instruction is going to be increment BX register if we are in 16-bit code and EBX with 32. So when incrementing this value sets 0 flag, then this means that it was executed as 16-bit. And then we have this error.